Now let's look at the second example. So in which both arrays need to be broadcast. A is equals to np dot range 3 dot reshape 3. B is equals to np dot range. Again, we'll start by writing out the shape of the arrays like this. A dot shape is equals to 3 comma 1, and it goes on. So rule number 1 says we must pad the shape of B with ones like this. And rule number 2 tells us that we upgrade each of these ones to match the corresponding size of the other array like this. Okay, so because the result matches, these shapes are compatible. We can see this here as A plus B gives the answer this. So now let's look at another example. Now let's look at an example in which two arrays are not compatible. M is equals to np dot ones. A is equals to np dot range. This is just a slightly different situation than in the first example. The matrix M is transposed. So how does this affect the calculation? The shapes of the arrays are like this. Again, rule number 1 tells us that we must pad the shape of A with ones like this. And by rule number 2, the first dimension of A is stretched to match that of M. Now we hit rule number 3, the final shapes do not match, so these two arrays are incompatible, as we can observe by attempting this operation. M plus A, this will give an error. Operands could not be broadcast together with shapes. So note the potential confusion here. You could imagine making A and M compatible by, say, padding A's shape with ones on the right rather than on the left. But this is not how broadcasting rules work. That sort of flexibility might be useful in some cases, but it would lead to potential areas of ambiguity. If right side padding is what you'd like, you can do this explicitly by reshaping the array. We'll use np.newAccess keyword, what we have observed previously. So now, in the square bracket, colon, comma, np.newAccess, square bracket close, dot shape. That results in 3 comma 1. Now M plus A, square bracket, np dot access, that results in this. Also note that while we have been focusing on the plus operator here, these broadcasting rules apply to any binary ufunc. For example, here is the logadep function, which is stated here. So which computes log exponents A plus B into the parentheses with more precision than the naive approach, which the naive approach is this: np dot log np dot new access, that results in this. So for more information on the available universal functions, we can compute the universal functions we discussed before.